we have to focus on these two things right now, IP address and subnet. I will discuss with you about the IP address and subnet mask in very detail in upcoming slides. So actual definition you can say is a 32-bit address. It is a 32 thorough knowledge of IP. And in my last video that I was recording on AWS VPC, that time also identify that I should repeat this topic. Otherwise, I already have a complete IP version 4 video series there on the my YouTube channel. But rather than watching the video series, now you can take the complete knowledge of IP in a single video. So please have patience, watch the video completely. After this, you need not, I think you will not get any question to ask me or to anyone. I will provide you a complete thorough knowledge in this. Okay, so let's start with the IP. So IP stand for Internet Protocol. The full form of IP term is Internet Protocol. It is a logical address assigned to every device in the network to identify the particular device in a network. Without having a proper IP, no device can communicate over the network. There are two types of addressing in the networking. One is logical address that I am showing you, and one is the physical address. Okay. So IP is a logical address, means can be changed, but every device in the networking have a physical address also, that is the MAC address. So I will not go in depth for the MAC. Right now we have to discuss about the logical address that can be changed with time to time. But without having a proper logical address, it's not possible to communicate over the network. Okay. So this is the structure like this. You need to configure on each device, like I show you my computer also. Network and sharing center, adapter setting here. I'm showing again properties. If you check IP version 4, here you can see we need to configure it. One option, obtain the IP address automatically, that is via DHCP server you need to configure. But manually, if you need to configure, you have to configure IP address, subnet mask, default gateway and DNS, so that your device will be able to communicate over the network or internet. Without having these settings, device cannot communicate over the internet. So just only for your reference that I shows you. Okay. So this is the IP address. So without having this IP address as well as subnet mask as well as gateway, your device will not be able to communicate over the internet. Okay, so you should have all these things. So we have to focus on these two things right now, IP address and subnet. I will discuss with you about the IP address and subnet mask in very detail in upcoming slides. So actual definition you can say is a 32-bit address. It is a 32-bit address, logical address divided into 4 octets separated by a decimal. Why it's bits here? Logical address or IP address is designed in binary number system, not in the decimal number system. I was showing you previously here This is a decimal number system. But actually IP is designed in binary number system. Hope you are familiar with bits and bytes term. So 32-bit divided into 4 octet separated by a decimal. Now what is this octet word? I don't want to leave a single word that make you confused. Octet is basically a collection of 8 bits. In normal, it is called byte. Collection of 8 bits is 1 byte. But here, in case of IP, it is called 1 octet. Collection of 8 bit called 1 octet. Collection of 8 bit called 1 octet. So let's check the actual structure of IP. This is the actual structure of IP. What I say is 8 bit separated by decimal, again 8 bit, then again separated by decimal, then again 8 bit separated by decimal, and then again 8. So 8 plus 8 plus 8 plus 8, 32 bit. Same for the subnet mask. 32 bit, 8 bit separated by decimal, 8 bit separated by decimal, 8 bit separated by decimal. So collection of 32 bit. Now, before proceeding, you must be familiar how we can convert decimal to binary and binary to decimal number system. If you don't have the thorough knowledge of this conversion, again become difficult for you when we go for the advanced topic of subnetting and VLSM or CIDR. So I'm not take much time because I expect that you all know, but still for easiness, I'm just taking a few examples here. Like I have taken decimal number system 92 and I want its binary number. So what I do? I divide by 2. Divided by 2. Then 96, remainder 0. 48, remainder 0. 24, remainder 0. Divided by 2. 12, remainder 0. Divided by 2, 6. Divided by 2, 3. Again 3 divided by 2, 1, and remainder 1. So now what I will like this way, from down upside. So 192, the decimal number system equivalent to this binary number system. Clear? So very easy, nothing complicated, just practice some few things, it will really clear to you. If I go the reversal process of this, look here. This was the 192 binary. So what we do here, writing is little poor. This is a 0 position, first position, second position, third position, fourth position, fifth position, sixth position, and seventh position. So 2 raised to power 0, 1, 2 raised to power 1, 2, 2 raised to power 2, 4, 2 raised to power 3, 8, 2 raised to power 4, 16, 2 raised to power 5, 32, 2 raised to power 64, and 2 raised to power 128. Okay, so 128 multiply by 1, it become 128. 64 divided by 1 becomes 64. Remain all are zeros, it becomes 0. So when we add, we get 192 back. So in this way, we can do decimal to binary and binary to decimal converter. Okay, same process here. 160 is the decimal number system, keep dividing by 2. Oh, what happened? Look here. 10101000. It will be the equivalent to 68. 10101000. Start from this side to this side. Same is the reversal process. 10101000. 2 raised to power 0, 1, 2, 3, 4, 5 up to 128, and it will be 168. I take it little fast, but still I think it's clear to you, just to revise you how we can do the decimal to binary and binary to decimal conversion. Comfortable up to this? Please do more practice for it. It will be very helpful for you in the upcoming slides to understand about the subnetting, even the structure of IP, even the class of IP. It is must for you to learn this thing. That's why I include here in the IP training. Okay. Suppose we have all ones. We have one IP in binary that is all 1. What can be the maximum value? 128, 64, 16, 8421, 255 means 8-bit value. 1 octet maximum value can be up to 255. So as I'm repeating, it's a 32-bit and divided into 4 octet. So minimum value can be 0 and maximum can be 1. What does it mean? What can be the minimum IP? All zeros. All zeros in a IP. And what can be the maximum? 1, 1, 1, 1, 1, 1. All 1 means all 32 1. So what can be the minimum to maximum value? When we convert it into the decimal number system for our easiness, what can be the maximum to minimum value? So we are discussing that what can be the minimum and maximum value of IP. So you can see here in decimal number system, the minimum IP can be 0.0.0.0 to 255.255.255.255. So this can be the minimum to maximum IP value. Maximum to minimum. Clear about the structure of IP? 32-bit address divided into 4 octet. Each octet have 8 bit. The minimum value can be 0.000, all zeros, and maximum can be all 1. When we convert this binary number system, I told you it's very important to understand about the decimal and binary number system conversion. So when we convert it into the decimal number system, it becomes 0.0.0.0 to 255.255.255.255. It is the structure, basic structure of IP. So please, if still have any doubt in decimal to binary and binary to decimal number system, please go and watch the video again and practice it. Okay. Okay. Next and most important also about the different class of IP. Class basically has been identified on first octet of an IP. Therefore, if you remember, there are 4 octets in an IP. Class is always identified on the base of first octet. What is the value of first octet? The base of that. We define IP class. So in last PPT presentation, perhaps you remember, minimum to maximum can be 0 to 0.0.0.0.0 and this was class. This first octet of any identity class. We talk about all the octet. Class is identified based on the first octet. Come to the classes. If octet can IP starting 0 to 120, 1 to 116. If any IP starts with 1 to 126, that is the A class IP. If any of the octet first octet starting 128 to 190 comes under the B class. If any IP starting with 190 to 223 C class, any IP starting with 229 is B class, any IP between just 225 is B class. Always keep it in mind. By looking at the first octet, with which class? A class, B class, C class, D class, or class. What we have seen that is a decimal point. Confused. Why it end with 126? Why it start 192? Why it up to 224 to 39? It's a little difficult. But actual reason behind this again something different. That is a dumb decimal number. The Y class end at 126. It can be 125 or 30. Y class end at 191. Can be 9. Easy. Remember, Y class end at 224. It can be 30. Actual reason behind this is I class has been designed in binary, not in decimal numbers. If I show you any IP in binary system, if I show you any IP in binary number system and ask you which class I belong, so by looking for first octet, if first bit of first octet is 0, you can say it's a class. If first 2 bit on any IP in binary system is 10, it is B class, and C class IP is 110. You can check it. N number equal to the binary between 1 to 1 is always 0. N number in between, so you can dot that is any number, make number it will come with 1 0, name the bit, can't any IP in between these two, don't even take. It first will be 110. So simply looking at the first octet bits, you identify that the decimal by looking at the first octet. So the class, the class, the class. But my purpose all these things to make you very familiar with the binary numbers. So this. When you about the class, A class and 126. B class 128 is your copy and pen ready. If your copy ready. And check 120 is not there. What do you use of that? 127. What do you use of that? 127 is used for self-test of machine and that's known as loop back I. What is loop back I? To check any single part is communicate. If the ready system arrives or not start properly, so we use that and different topic discuss. So 127 is known as the loop backs. So when we talk about an IP, I'm taking one IP here. I'm taking one IP here, 192.168.1.10. So get 192.10.10 IP. How can I identify which an IP? So host part is network, and this is the host dedication on the network, another machine network, like a city, and then house numbers. How we can identify that this is a complete network, and this is a device side network. How we can identify? So when we take any IP, out of 32 bit, some bit identify you can pick a city name, or a state name, or a country name. It's like telephone number. Click for India. Always start it. First time. So this particular that is a and name some portion of ISP or service provider, and then a particular identify a particular mindset. We say we can some portion identify a particular network, and some portion of it identify a particular device. Okay. So how do we identify that? Which portion of IP belongs to the first and which is in the host part. So each IP consists of two parts. Some IP are networks and some are hosts. How do we identify them? Then we identify with the help of subnet mask. We have seen the structure there. I show you first is the IP address and next is the subnet mask. So we identify. We have a submask. Each class. What if I want to more clear perhaps? Let me check. So these are default subnet masks. For A class, the default mask is 255.0.0.0. B class, first 2 octet belong to 255 is 111. Convert it again and using everything 1 or 0 means binary numbers. So this is the current byte will be 111. So in a subnet mask, one portion represents the network, the nature first is network portion remain all other host. First two is the network portion remain to other host part. And see classified as zero. In the three relates network last factor is you convert will be zeros. Then port. That's then class. That is in the first three is one of these be body check. If so is positive, first three is C class. This like one mask is all like this net mask. So now I so finally understand the IP addresses. The so come here. If I configure some IP manually here, change it after setting, properties, and I try to set it. Sorry, dot 0.20. I don't post. And when we go subnet mask, it automatically a class default subnet mask that is 255.0.0 dot so that was shown here. A for B class, B class ID, and when I take a say so this is about the subnet mask. And when we compare the IP up to here, first 3 octet host in a network. Host it will remain same in the same portion remain in the same network, and this always varies for one network. It will be suppose one device let's go to 1/3 2 then next 3 as much as you have we put different host rates. And subnet mask always discontinuous. What here like this 11000101010 that if one network is going it always can be like 10 it can never be possible. Subnet mask is always contagious, keep it in mind. Contagious. Okay, so if we take example side understand it carefully. I'm taking this IP series 192. 168 1 default subnet mask is this one. So what I want to show you here, look. So now see very carefully. First IP is known as network IP. Please take the notes. Then it is the subnet mask. By default, subnetting. That time we change it. Subnet mask. Then what? First valid IP. What is first valid? The IP that we can assign to the devices. So it keep changing. It will not change. It will keep changing. 2, 3, 4, 7, 8, 9, and can go up to 254. It is known as last valid. It is the broadcast IP. It's known as broadcast. On first type is known as the you see 1 1 2 3 4 5 6 7 8. All the host bit become saturated now. We don't have more space before. It is known as the blast. And is a network IP. But if we go very depth, this IP is used by the routers to communicate in different networks. And this IP is reserved for broadcasting in a whole network. So this is the valid IP range. Only we are doing the change in host bit of a subnet. I think that this portion is the network portion. It will remain same. You can see here up to here it is same. From one device to another device, this host bit keep changing. 1 2 3 4 5 6 7 go 100, then 100 1 2 3 and go up to 254, and last broadcast type is 255. Clear? See more example perhaps. We talk about the BLS IPC. I'm going to give you very much examples. So now BLS 172.168.0.0. Wait, 172.168.0. We will start from this side to this side in a host. It can go now seconds, then it become 1.00 side and go up to this side. 2, 3, 4, 5, 6, go up to 2. Don't worry. Stay that. Again the counting start 1 0. This is also valid IP and this is valid. In the host portion, it is on or one. So network is it is the last valid IP of the in between IP exists here. First 16 bit is empty here. 8 bit plus 8 bit, 16 bit. So it's and it will be broadcast IP. Let's go to the broadcast. Very lengthy network. Otherwise, please see another video. If so to the class, a single bit is off. Here 8 bit here and 7-bit error. So it's not one. Always 0, 0, 0, 0, 5, 6, 7, dot 1, 2, 3, 4, 5, 6, 7, 8. It is the binary conversion. Means single bit is on, single bit of 1, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7, 8. Single bit is on, that valid also. But when all off network ID and when all bit is on, that is the process. So you see the last example also. For this for sure. Subnet. What is the broadcasting? It will be the become saturated. There is no more host. Host.